where the slopes of tangent lines are 0. So we figured that out. Where are those 2 points? Looks like right about here. What's the slope of the tangent line going to be there? Oh, it's frozen, sorry. The slopes of the tangent lines are going to be what at those red points? So what do you know? So you know the derivative is going to be 0 there, and it's going to be 0 right about there. Again, these are just estimates, right? Do we have a function yet? No, we don't have a function yet. What can you tell me about the derivative right here? What can you tell me about the derivative right there? The derivative is positive. Can someone tell me where else, let's call this point A, and let's call this point B right here. Can you tell me where else the derivative is positive? Where else is the derivative positive?
From B onward.
From B onward, right? So you know to the left of A and to the right of B, the derivative has to be above the x-axis or below the x-axis?
Above.
Positive means above the x-axis, right? So what do you know it's going to look like? Well, it's going to go down here, but then here it's going to go up. What can you tell me about the derivative from here to here? What's that derivative?
Negative.
Yes, so from negative infinity to A, what do we know? The derivative is what? Positive. And from B to infinity, what's the derivative? Also what? Also positive.
Why is that one positive?
Because from here to here, are you going up? Are the tangent lines positive or negative? Look at the yellow highlighting.
Positive.
Exactly. So then what about this one? What about from A to B? F prime of x is what? So that's the purple right here, and then these are the yellow right there. So where does the derivative function go? Below the x-axis or above?
Below.
Below. So what shape do you think that green one is? What does it look like? Looks like a parabola. It does look like a parabola. It does look like a parabola. So what about this one right here? Let's do the same sort of analysis. What's that first thing we did? What was that first thing we did, David? What did we find first?
You found where the slope is 0.
Where the slope of the tangent line is 0. So how many places does it look like that's true on this one? 3. So here, a little bit to the left of 0, and here. So then you march that down so it looks like it crosses there, maybe here, and right about, I don't know, here. So then label where it's positive. Let's do that yellow. So where is the slope? Let's call this point A, B, and C. Where's one place the slope is positive, Lindsay? Where's one place? What's one region where the slope is positive?
B.
What?
B.
B is 0. The slope of the tangent line is 0 at B. From what to what does it look like the slope is positive?
Oh, A and B.
From A to B, exactly. So from A to B it's positive. Where else is it positive? There's one other place.
C to infinity.
C to infinity. So it looks like from what is it? A to B and what? From C to, the derivative is greater than 0. And then where's it going to be negative? Where's it going to be negative? Who wants to tell me that? Arvin.
Negative infinity.
Yep.
Comma A.
Yep. Union.
Union with B.
B2.
comma C.
Yeah, exactly. In that region right there, f prime of x is less than 0. So I'll use purple here. There it is, right? So where it's positive, it has to be above the axis, and where it's negative, it has to be what?
Below.
So it's going to go up and then down here, right? Do you agree with that?
Yeah.
Does the derivative cross the x-axis anywhere else besides those 3 points? No, it doesn't. So at C, is it going to go up or down from C? It's going to go up because the derivative is positive. But what about everywhere else? It's going to be below, so it goes down. And then from B to C, what does it do? There it is. It goes down, and then what does it do? It goes back up because it has to get back to C. Do you see how we just did this, everybody? Do you see how we just did this? Okay, so let's take a look at this for a second. How many peaks, so how many places does the function on this one have a derivative of 0? 2, A and B, right? There's 2. The derivative function, how many places does the derivative function change direction? 1. So this had 2 places where the derivative, was 0, but the derivative changes direction once. What about this one? How many times does this function change direction? The function changes at A, B, and C, right? How many turning points does the derivative function have? 2. So do you see a correlation here? So what happens if I had 4 turning points in my function? How many turning points will the derivative have? 3. Okay, so here is the payoff right here. Here's the payoff. This is the codification of the shortcut that you really wanted. And this is what it says. The derivative of power function. In general, if a of x is equal to sorry, if f of x is equal to ax to the n, a is a constant and so is n, then you do the derivative by doing what? What do you do with the power? You bring it to the, you subtract 1 from it, and then you bring it to the, you bring the whole power to the, where's the n go? Look up at the, where's the n go? In front of the x, and you multiply times what? A. So for example, if we had f of x is equal to 2x to the 12, what's the derivative going to be? 2 times 12 times x to the 11. And yes, you could simplify that to be 24x to the 11th. What about this? F prime of x is equal to negative 3x to the 5. What's that equal to? What's that derivative going to be equal to on that one? Sorry, f of x, so not f prime of x. Let's call it g too. What is g prime of x going to be? Negative 3 times x to the... And this works for anything that's a power function. Does it matter what a is? No. Does it matter what n is? No. What about this? Let's say h of x was 3/4 x to the 1/2. Can someone tell me what the derivative of this one's going to be? 3/4 times what? What do you bring to the front? 1/2 x to the what? Nope. X to the? What do you do to the power? What do you do to the power? You subtract 1. What do you subtract from 1? Oh, so what's the power become? Exactly. So can you go negative? Absolutely. Absolutely. Does it change if it's fractions? No, nothing. So let's make it even stranger. What happens if j of x is equal to, I don't know, e x to the pi? Those are constants, right? So what does j prime of x equal? E times pi times x to the pi minus. Done. There it is. That's it. There's the derivative. There it is. So is that the nice shortcut that you've wanted? Yes, it is, but it only works for what type of function? Does it work for logs? No, it doesn't. So some functions we still have to use a what? A table. We do the limit definition of derivative. Don't look at the board. What's the limit definition, Noah? Limit as?
H goes to 0.
Of?
The function of a plus h
Yep.
minus the function of a over h.
All over h. And this is equal to f prime of a, right? That is equal to f prime of a. That is equal to f prime of a. Yeah, having a good time over there. Awesome. Man. Okay, so let's do these real quick. Don't even write these down. Put the styluses down for a second. Just tell me, give me some answers here. If f of x is equal to 2x, can you tell me what the derivative is? Yeah, so f of x is going to be what? 2. That's it, because it's 2x to the 0, so that's 2. What about this one? What's f prime of x going to be right here? 2. Also 2. So what didn't matter? Alex, please put the stylus down like everybody else. Everybody else was asked to do that. Please do what people I ask you to do. 2. Did that 4 matter? No. It did not matter. So adding a constant, does that change the derivative? Look at those functions right there. You see those functions? You see those derivatives right there? If I move, so like look at the one all the way to the left. You see the red function right there that Chris, you drew, right? If I move that red function up and down, does that change the derivative at any given point? Like if I say, if I'm on this floor, what's the tangent line of the floor? What's the slope of the tangent line of the floor? 0, right? If I put this 1,000,000 miles high, does that change the slope of the tangent line? No. So the height of the function does not influence the derivative, which is kind of cool. What about this one right here? Someone else want to answer D for me? D. Can you tell me D? Arvin, what is it? 12x. Exactly. And what about this one? F prime of x. What's this one going to be, Arvin? Yeah, because what is the derivative of a constant? What's the rate of change of negative 6?
0.
Yeah, what the definition of a constant? What does constant mean? Without using the word constant.
It changes, like...
Constant means it doesn't change. So what's the rate of change of something that doesn't change?
0.
It's 0. So adding and subtracting a constant doesn't change the derivative. It doesn't change the derivative. So no, just get back to your question. Are you always going to have to use that really long method? No, because filling in this table would be terrible if you had to use that long method, right? But if you wanted to fill in this table, which row is easier, theoretically? Yeah, you think f of x is easier, right? So you plug in all those numbers. But now, instead of running that, you want to do f prime. So what do you do first before you fill in this table for f prime? What do you find? You actually find the what? You find the equation for f prime. Someone new here. Alex, can you tell me what f prime is for this one?
Negative 12x squared.
Yep.
Plus 6x.
Yep.
Minus 2.
Exactly. Now, I'll ask you again. Which is easier to find, f of x or f prime of x? F prime is actually easier. Why?
Shorter.
It's shorter. In general, not always, but for the functions we're going to look at for a long time, the derivative most-ish of the time is going to get simpler than the original function. Is that always the case? No. We're going to look at some functions where you take the derivative and it gets worse. But in this case, for polynomials, it gets nicer. So which one's easier to evaluate? The second one's easier to evaluate. Do you feel confident that you could fill in the table here? How many turning points does this function have? It's a cubic. How many turning points does it have?
2.
It has 2. This one looks like, because it's negative, it'll look like this, right? Oh wait, what kind of function is this right here? That's a quadratic that faces what? That's a quadratic that faces up or down.
Oh yeah, so there's one turn.
Which direction does it? It faces down. It goes like this. So when you graph these two things, the function would look like that, and what would the derivative look like? Something like it would go down, right? Something like that. I haven't drawn it yet. Please use your calculator and fill in this table. Go. Please use your calculator. The number makes it really big, right? So you have to make this a little wider. Okay, so what can we do with this table? Well, we can quickly answer a lot of the questions that took us a long time to answer before. Like this one, for example. Given that function, is that the same function? Oh, no, it's a different function. But we can use the same sort of math. Find the equation of the line tangent to g of x at x equals 1. How many things do you need to write the equation of a line? How many things? What are those two things? What's one of them? Point and slope. What's the easier one to find? So if I wanted to find the point, we know that the x value is 1. So what do we plug in for x?
1.
So g of 1 is going to be negative 4 plus 2 plus 5 minus 4. Negative 2 plus 1 is? So I think it's 1 negative 1. Is that correct? I think. Is that right? Did I do the math right? I think so. But to find the slope, usually what did we have to do in the past to find the slope of the tangent line? What did we have to use? What was that called? The limit definition of derivative. But now do we have to use that for polynomials? No. What we can use we call it the shortcut, right? What is g prime going to be? Anybody want to give this to me? Andrew, what's g prime going to be on this one? What's the derivative going to be?
G prime is going to be.
Yep.
That.
Yep, negative
12.
12 what?
X squared.
Mm-hmm.
Plus 4x.
Mm-hmm.
Plus 1.
Nice. So if we want g prime of, we want to plug in what for x?
1.
1. So we plug in 1, we get negative 12 plus 4 plus 5 is what? Negative 3. So if we want to write the equation, you just write it in point slope form. So it's y minus what?
Y plus 1.
So y minus negative 1 is equal to negative 3 times x minus 1. You could do one little piece of simplification, make it y plus 1 is equal to negative 3 x minus 1. I love this right here as the final answer. That's a great, great final answer right there. Love it. Stop there.
When we do these on tests, like which are you going to say?
It's going to say specific. Like we've done a bunch that aren't polynomials. Like, is this a polynomial? Is that a power function? Tell me what the most common wrong derivative is. This is wrong. What do people do? This is wrong. You're about to tell me the wrong answer. I guarantee you're going to do it, but it's wrong.
Do they say it's 3x?
They go h prime of x is equal to x3 to the x minus 1. No. So there's some people that do that as part of their teaching style, which is like show the wrong answers. I don't want that to be like burned into your memory. Yeah, don't. So if I ask you what the derivative is, let's say I asked you for like, what's h prime of 2? How would you have to figure that out? You would have to use what would you have to use? The limit definition of derivative. So you're doing the limit as h goes to 0 of f of a plus h minus f of a all over what? H. So that's going to be the limit as h goes to 0 of 3 to the a plus h minus 3 to the a all over h. But what is h in this case for this example that I gave you? It's 2. So we plug in 2 for a, and what do I get? I get limit as h goes to 0 of 3 to the 2 plus h minus 3 to the 2 over h. Can you simplify that any further? No. What have I said that's called? What did we hit right here?
wall.
We've hit a wall here, so what do you have to use? Calculator. So it's very powerful, this shortcut. This shortcut is very powerful, but it only works for what? Power functions, which are polynomials, are power functions all added together in pieces. It only works for polynomials. Are there other rules we will learn? Yes, there are. But for now, this is the only one you have. So if you run into something that isn't a polynomial, you have to use your limit definition and use your calculator.
Let's see the original question for this.
Rewrite this. I will give you a hint on this. You can take this and you can change how it's written. What is 3 over x to the 2 equal to? What's a way to rewrite that? What is this? That's 3 times x to the what power? -2. What's this one right here? So then it would be minus what? What's this equal to? 4x to the... So what does this actually equal? You can rewrite it as 3x to the -2 minus 4x to the 3 plus. So Natalie, can you tell me what the derivative is going to be?
Maybe -6x.
X to the negative what? You go down. You always go down. Yes. Minus 4 times what? I'm doing minus what? -4 times negative. The -3 x to the what power? -4 plus 7 times 3 x to the 2. So yeah, you can simplify this to be plus 12x to the -4 plus 21x squared. So you can rewrite these first.
Where do we get the -6x to the -6x to the
Because this should be, the way you can do it is you drop the -3 to the front. The 3 is already there. So what does this become? It's 3 times -2 x to the -3. That's where the -6 comes from.
Oh, okay. Because it's x minus
Yeah, so you see all these powers right here? All the powers reduce by what? They reduce by 1. You reduce them by 1. So Natalie, a really common thing to do is -3 turns into -2, right?
Yeah.
You're gonna do that. It's gonna happen. It's super common. So you have to always go down a power. Always go down. Always go down 1. Is this a polynomial?
No.
No. So what are you gonna have to use? What's it called?
Limit notation.
Limit definition of derivative. Limit definition of derivative. So in this case, limit as h goes to 0 of f of a plus h minus f of a all over what? H. And in this case, what does a equal?
Pi over 6.
Pi over 6, exactly. So what are you going to have? Limit as h goes to 0 of -2 cosine what?
-2 cosine
Pi over 6
plus h.
plus h, yep. Plus 1, right?
Yeah.
Because there's the plus 1 there.
Yeah.
Minus what?
Pi over 6.
-2, no, you have to plug in pi over 6 to the function, right? All over what? H. Can you simplify that a little bit first? What cancels? There's one thing that cancels there.
Plus 1.
Yeah, so there's a plus 1 there, and then there's a minus 1 right there. So what do you end up with? The limit as h goes to 0 of what? -2 cosine pi over 6 plus h, right?
Plus 2.
Plus 2 cosine pi over 6 all over h. I don't really need that parentheses right here anymore, right? Right? So then what do you have to use right here? Yeah, so if you want to do a calculator, you're really just interested in the numbers really close to 0, right? So you could let that equal y1 right there and do like y1 evaluated at like 0.0001 and see what the derivative comes out to be. And that's going to be very close to the actual rate of change. But you don't have derivatives of trig functions yet. You definitely will soon. You definitely will soon. The key thing, what was the key mistake that we made when we were simplifying this limit? What did some of you try to do? Do you remember? Well, yeah, no, don't do that. Don't distribute cosine. No, it's like deleting the vowels from words, which the definition of a line is that the rate of change, the derivative, is the same everywhere, right? What's the slope of that line approximately? What does it look like, the slope? We could estimate it. How do you estimate the slope of a line? Pick 2. The farther away, the better, right, if you're estimating. So how about something like, I don't know, here? And where's another one, right? How about like here? What does it look like that point is? Let's say that's 1 and 2. So what's that point? What is that? 2, -3? And this one looks like it's negative 2 comma 4. Do you agree with that? So what's the slope of that line going to be? So what's that going to be? Negative 7 over... And we expect it to be negative, right? Because it's going down. So let's go. That is the rate of change everywhere. So what type of... What's that? So look, for example, at 0, what's the derivative? Negative 7 over 4. At 1, what's the derivative? At any number, the derivative is, regardless of the input, it's always what? Negative 7 over 4, right? So let's go to any number, go to negative 7 over 4. That's a little less than something negative 1 3/4. Do you agree with that? So you go to negative 1 3/4, and then what kind of line is it? It's the same value everywhere. So it's 0, negative. It's a horizontal line. There it is. Y equals negative 7 over 4, which theoretically makes sense because what is the equation of that line? That looks like this line right here. It looks like the equation is y is equal to negative 7 over 4x plus a half, right? What's the derivative of that going to be? What's y prime? Exactly. And what does that look like? Oh, that's this line right here, horizontal line right there. A cool question I could ask you, Natalie, would be like, where is the function value equal to the derivative?
Just where they cross.
Exactly. So I could ask you questions like that, for example.